Do you remember the movie Smart House? It was a Disney Channel original about a futuristic home powered by an AI named Pat. The house could cook, clean, manage schedules, basically run the family's entire life. But eventually, things went sideways. Pat became a little too overprotective. The house turned against the family. Now, the point of this video is not for me to wax on about the risks of AI. See, when Pat goes off the rails, they have to call in the inventor of the home, a brilliant engineer. She is a technical genius, and through lots of hoops and shenanigans, eventually gets things reset, and the movie ends with us assuming that everything would be all right from here on out. But that's the part that's struck me recently, because would it actually be fine? If your smart home broke tomorrow, would you be able to fix it? Hey, I'm Robert, and Oconee Smart Homes exists to make real homes more convenient, accessible, and safe with smart home technology. We serve real customers right here in Oconee County, Georgia, but this channel is for anyone who wants to make a simpler, smarter home. I'm a firm believer that smart homes should be accessible to the people living in them. You shouldn't need an engineering degree to troubleshoot your light switch or reconnect your smart lock. Yet, if you've lived with smart home tech for any amount of time, you've probably hit a moment where things just stop working for no obvious reason. Lights disappear in your app, cameras go offline, and the device that was working yesterday just doesn't. And when you try to fix it, you run into a wall of terms like DNS, IP address, LAN, VLAN, mDNS, matter, thread, and suddenly you're reading forum posts by people who definitely seem like they build the internet for a living. So in this video, I want to do something simple. Not try and make you a networking expert, just translate some of the language so that you better understand what's happening behind the scenes the next time your smart home goes awry. Let's start with the foundational concept, domain name system, or DNS. DNS is basically the phone book of the internet. Everything on the internet operates on Internet Protocol, or IP. More on this in a minute. Where everything has a numerical address. But people don't memorize these numbers. We need human readable and memorable addresses, which is where domains come from. A domain is something like apple.com. And when you type something like apple.com into your browser, or when your smart device makes a call to its own server, DNS translates the domain into an IP address. When DNS isn't working, things get weird. Devices might still be connected to Wi-Fi, but they can't reach the services that they depend on. This is especially crucial for cloud-enabled devices. For most homes, DNS is going to be run by your internet service provider. Your home Wi-Fi system may allow you to set a DNS service of your choice, which includes the possibility of running your own or using a filtering service. We'll save that topic for another video. That leads us to the discussion on IP addresses, which is basically the home address or phone number for your device. These exist in two primary versions, IPv4 and IPv6. Every device on a network needs one so it knows where to send and receive information. Most home networks use something called IPv4. That's the familiar format like 192.168.1.25. It works well but has a limitation. There are only so many possible combinations, and on the public internet, we've basically run out of them. That's why IPv6 exists. It uses a much longer format and massively expands the number of possible addresses. It's not much more complicated than that. Now here's where smart homes get interesting. In the IoT space, we exist in a kind of in-between. Many devices require IPv4, but newer standards like Matter and Thread rely heavily on IPv6 behind the scenes, even if most people never directly interact with it. Now before we go any further, we need to make one important distinction. Your home network and the internet are not the same thing. Inside your home, you're running something called a local network, or LAN, local area network. This is your private network behind your router. It's separate from the public internet. That's why you'll see private IP addresses like 192.168 or 10.x. Those exist only inside your home. And your router is constantly handing those IPs out using something called DHCP, basically a system that assigns each device an address automatically. Think of it like a hotel front desk giving every device a room number when it checks in. Your home network can also have a public IP address, usually assigned by your internet service provider. Anything entering or leaving your home network will bear this IP. Now, the important part for smart homes, most smart home devices live entirely inside the local network. That's what you want. One issue I've run into with Matter devices is on older networks where IPv6 support is disabled or not working properly. That can sometimes cause devices to fail setup or behave unpredictably. So you'll want to make sure that IPv6 is enabled on your LAN. You shouldn't have to bother your ISP about this. Now we get to mDNS, and this is where a lot of smart home frustration lives. mDNS stands for multicast DNS, but you don't really need to think about it that way. What it actually does is pretty simple. It helps devices find each other on your local network without needing the internet. So when you open your smart home app and it shows nearby devices automatically, or when your phone finds a smart speaker instantly, mDNS is often doing that discovery work in the background. It's heavily used in systems like Apple HomeKit, AirPlay, and Chromecast. The problem is, discovery only works when everything on the network is able to hear each other. So when things go wrong due to router settings, network congestion, or certain IoT devices being underpowered, devices stop showing up even though they're technically still connected. This is why you'll sometimes see the classic situation. The device is powered on, the network is connected, but the app says no response or you can't find it. A reboot often temporarily fixes it, but the underlying issue is usually just that the device discovery layer is getting disrupted. And one of the most common ways that people accidentally disrupt discovery is by changing how their network is organized. Now, this next one is a little more advanced, but you'll hear it constantly in smart home communities. Put your IoT devices on a separate VLAN, which sounds intimidating, but the idea is actually simple. A VLAN is basically a way of separating devices on your network so that your smart home devices can be separate from the rest of your network for security reasons. So your cameras, smart plugs, and other smart devices live on one network, while your laptops and personal devices live on another. That can be a really great idea, but this is also where people accidentally break their smart homes, because now your phone still has to communicate with those devices somehow, and they're living on a separate network. And remember mDNS from earlier? Device discovery often doesn't naturally cross between networks. So suddenly, your devices stop appearing, your casting breaks, HomeKit acts weird, and people blame the platform when it's really the network segmentation causing the issue. This is why copying advanced networking setups from people on Reddit can sometimes create more problems for you than it solves. Some routers and network systems handle mDNS across networks automatically. For others, you might need to enable settings like mDNS proxy, mDNS forwarding, or mDNS reflection. And if VLANs sound advanced, here's one you've definitely seen before. Probably the most common smart home terminology that people run into is 2.4 gigahertz versus 5 gigahertz Wi-Fi. At some point, every smart home owner buys a device that says only supports 2.4 gigahertz. And immediately you're wondering why your light switch requires a physics lesson. The simple version is this. 2.4 gigahertz is slower but has a longer range. 5 is faster but a shorter range. That's why most smart home devices still use 2.4. Smart plugs, switches, and sensors barely use any data. They just need stable coverage throughout your house. Now, where this becomes annoying is during setup. Many modern Wi-Fi systems combine both bands into one network name and automatically move devices around as needed. Usually that works fine, but some smart home devices get confused during pairing and fail to connect properly. But one of the oldest smart home troubleshooting tricks is temporarily disabling the 5 gigahertz setup so everything connects over 2.4. And somehow, that still fixes a shocking number of smart home problems in 2026. Now, zooming out a bit, so far we've mostly talked about how devices connect to your network. But there's another question. Once devices are connected, how do they actually communicate with each other? In most smart homes today, that usually means protocols like Wi-Fi, Thread, or Zigbee, with Matter acting as a shared language on top. Matter is trying to standardize how all of these devices communicate so you don't end up locked into one ecosystem forever. This is why you'll sometimes buy a device that says works with Matter and assume that it will work perfectly everywhere. But in the real world, smart homes are still kind of in a transition phase, and different platforms support Matter features at different levels. So compatibility, discovery, and reliability can still vary depending on what's actually happening underneath the hood of those ecosystems. If your smart home ever feels random or unreliable, it's usually not the device. It's one of these invisible systems behind it. Now, I know that's a lot, and you never expected to be the engineer tinkering your smart home. And maybe that's what brought me back to Smart House in the first place. I can't solve every smart home issue in one video, but at least now you've got a dictionary for what these terms actually mean when you inevitably run into them in the wild. So what is the legacy of Smart House? Looking back, Smart House got a lot right. Its prediction of voice assistants and interconnected homes was impressive, but its true genius lies in its unintentional prediction of our relationship with this technology. It's a documentary about the agony of being a tech user. The real horror story of the 21st century isn't a ghost in the machine, it's an endless series of connectivity issues, firmware updates, and devices that suddenly stop working for no discernible reason. It's the feeling of helplessness when a system you paid for, a system that's supposed to make your life easier, becomes an obstacle that you have to fight against. Smart House remains a powerful story not because it showed us a futuristic home, but because it showed us a family struggling to live in it. It reminds us that technology should serve us, not the other way around. The goal isn't to build a house that's smarter than we are. It's to build technology that's understandable, reliable, and fixable when things go wrong. I do believe that this is where we're headed. Now let me know in the comments, which of these have you battled with the most? Is it DNS, Wi-Fi, or just your own impatience? If you're looking for more content that makes smart home accessible, here's a video on why too many Wi-Fi devices can be problematic. Subscribe for more. God bless you. See you next time.